if you're in the UK at least, you probably would have heard of something known as a flame test. You may have done this inside of your GCSE or IGCSE or whatever sort of further education qualification classes you may have had, where you will put some metal solution, so the ions are in there, under a flame with some sort of wire or something, and it will turn into loads of cool different colours. Now I want to explain why this happened, not just what colours there are and this and that and etc, etc. Why these colours actually appear when something is burnt in a flame. Maybe I'll try get some clips online of these flame tests in case you've never seen it before I actually go on to explain how this stuff actually happens. But yeah, I remember doing this, and certain elements turn different colours. Like lithium was like a bright, not like bright red, but like a dark crimson blood red, and some like sodium and calcium. It was funny because sodium and calcium respectively, I think it's like orange and yellow, and it didn't really change the colour of the flame because orange and yellow is the sort of colour of sort of safety flame that we were only able to use. But other than that, there was potassium, which was like purple, which was like really cool, and there was copper, which was like Northern Lights kind of green. I wonder what the Northern Lights actually is. Maybe I'll actually explain that in another video as well, how the Northern Lights works, because that's probably something to do with chemicals that refract or refract or absorb different wavelengths of light. That's probably an interesting thing I could talk about as well. But on to how these sort of flame tests actually work to test and detect certain ions. I'm pretty sure it's only for positive ions, probably even only positive metal ions as well, because the way that it works is when you heat the ion up, when the ion has been in a solution, it's going to excite the electrons. The heat will excite the electrons. It will jump to energy levels. You may have, if you've done some science stuff, energy levels in sort of how atoms work. Like the lower down you go in the periodic table, the more energy levels there are, and that kind of stuff. But the electrons that are going to be in lower energy levels, like imagine potassium. Potassium has, I think, 4 principal energy shells, and then when it's heated in a flame, maybe one of the outer ones are going to go to the 6th or the 5th, or somewhere in the 5th and the 6th, the different orbitals that exist inside of those certain principal energy levels. But it can't stay there for long because it's so unstable. So it's going to fall back down to its actual place, and that falling back down releases a certain wavelength of light that we are able to see in our eyes. That means that we can actually see this kind of colour. Maybe the reason it doesn't work with negative ions is because that may not be able, the fact that it has more electrons than protons and it's negatively charged means that the electrons jump so high that when it falls back down, it has such a high wavelength that we as humans are not able to see it. That may be something that happens. I don't really know. I haven't thought of an explanation for that, nor have I researched it, but that's just a potential thing that could actually happen. But I know this is only for positive ions, and that could be another reason. Another reason is that negative ions may just not jump at all. I'll maybe put a more advanced explanation on text as well. But hopefully after this explanation, I'll put some more clips of these cool flame tests up and stuff. And yeah, that's basically it. That's how the flame tests that you may have experienced and seen in your GCSE classes or school classes actually work. That's how these things are able to function. But with that, I recommend subscribing for more content like this, and have a good day.